So our goal is to develop a virtual reality platform that can help improve diagnosis in conditions like depression, bipolar disorder, and personality disorders. So by tracking behavioral and physiological responses, we hope to offer an earlier, more accurate diagnosis.
Welcome to the Brains on Brains podcast, brought to you by ECNP, where early career scientists speak with the most interesting experts in applied and translational neuroscience.
Hi everyone, welcome to the ECNP podcast. My name is Michele De Prisco. I'm a psychiatrist and early career researcher at the Bipolar and Depressive Disorder Unit at the Hospital Clinic in Barcelona, in Spain, and I will be hosting today's episode of the ECNP podcast. I'm very honored to have here with me Professor Kamilla Miskowiak from Copenhagen. Thank you so much for accepting our invitation. Professor Miskowiak is a distinguished researcher. She's full professor of cognitive neuropsychiatry at the University of Copenhagen in Denmark. And she leads the Neurocognition and Emotion in Affective Disorder Center in Copenhagen and also the ESBD Targeting Cognition Task Force, including 24 international experts on this topic. She published more than 250 publications indexed in PubMed, and she is primarily interested in cognitive aspects in mood disorders. With her team, she both works on the diagnostic and interventional side of this topic, aimed to identify brain-based biomarkers, develop new neurocognitive screening tools, and providing innovative biological and psychological treatments for cognitive impairment. Today, we'll be discussing about the implementation of virtual reality in neuroscience, but before going deep in this topic, I would like to start with a broad question. So when and where did your interest in cognition and mood disorder actually begin?
My interest in mood disorders began already during my studies when I was an undergraduate in Copenhagen, and I was very interested in the effects of the drug erythropoietin, and EPO, it's best known for blood doping, and I was very interested in the effects it had on the brain. So it has an effect on neuroplasticity, and I started some experiments with rats swimming in water mazes, and I later took that during my master's in Oxford. I took that further to investigate the effects of EPO in humans, looking at antidepressant biomarker models and also on cognition and using neuroimaging and cognitive tests. And the findings were really very promising. And so that really sparked my enthusiasm for investigating effects of different types of pro-cognitive treatments in mood disorders.
Okay, so nice. I've been working with bipolar disorder, I think, since the beginning of my residency. And I understand that not so many psychiatrists go beyond depression, mania, hypomanic symptoms, which is quite problematic, I suppose. So how this interest of yours actually changed your clinical approach? And maybe how do your patients have responded to this particular interest of yours?
Our research into cognitive impairments in mood disorders has significantly impacted on my clinical work and my clinical approach to patients. So 3 key insights stand out from our research. So the first thing is that around 50% of patients with mood disorders experience cognitive impairments like memory and planning difficulties, even after the symptoms of the mood disorder subside. And these impairments greatly affect their daily lives as well as their work and social functioning and also the prognosis, so leading to increased relapse and hospitalization risk. So that was one of the insights. And then the second insight is that there are limited treatment options for cognitive impairments in mood disorders. So the most promising ones are cognitive remediation interventions that involve cognitive training, much like exercising the brain. And that's paired with compensation strategies like using alarms or calendars. And it is essential to combine this in the intervention and also to focus on transfer to daily life so that people who benefit from these treatments also benefit in their daily lives. So this transfer is actually a very big challenge in the field we may come back to with virtual reality a bit later. And then the last insight is that we found a discrepancy between self-reported cognitive difficulties and objectively verified performance decline on neuropsychological tests. So this discrepancy means that it's not always the patients who complain the most who show the greatest objective deficits. So this really means that we need to combine both subjective and objective measures of cognition when we do screening for cognitive impairments. So based on these insights, we've introduced systematic cognitive screening for mood disorders in patients in our clinic, in the Affective Disorder Clinic in Copenhagen. So we guide the patients based on the profile of cognitive impairments and also help them manage the challenges in their daily life. And for those who are cognitively normal, we assure them, because a lot of patients are really worried about their brains, that their brains are not working or they've been impaired in some way. And these patients really benefit from the reassurance that they are actually performing within the cognitive normal range. And then on the research side, we're exploring different pro-cognitive treatments. So this can be virtual reality-based cognitive remediation interventions that we'll talk a little bit about today, I understand, and also biological interventions to improve cognition and thereby functioning in these patients.
Okay. So I think that we should stop teasing our audience about the main topic of this interview, and we should start speaking about virtual reality. It's very interesting, your work, and I think it's very important that something that, as you said, is experienced by more than 50% of the patients is not receiving maybe the necessary attention that it should. So in recent years, I think that you start assessing new ways to explore cognitive deficits in people with mental disorder, and one of these, as you said, it's virtual reality. And what led you to use this specific technology?
So what led me to explore the potential of virtual reality was really the challenge with neuropsychological tests. Okay. The main challenge is the limited ecological validity. So neuropsychological tests involve specific instructions that are given to patients in a quiet setting without disturbances. And this really does not resemble patients' daily life cognitive challenges. So normally they don't have any instructions and they have plenty of distractions. And therefore, it's not surprising that neuropsychological test performance accounts only for between 5 and 21% of variance in patients' functioning. So really indicating that they provide limited insight into how patients function in daily lives. And so here, virtual reality platforms have a huge advantage. So they enable simulation of naturalistic cognitive challenges, such as cooking a meal or going food shopping, while still maintaining a very controlled experimental setting. So in that way, virtual reality offers a promising modality for measuring real-world cognitive functioning. So this is important both in research for investigating new pro-cognitive interventions and also in the clinic, where it's important for evaluation of patients' everyday life cognitive functioning.
I think that I'm quite lucky because I'm working in Barcelona. I had the opportunity to actually test the cognitive assessment in virtual reality test, the cover test that your team developed in Denmark. And it was a very pleasant experience. It was real, I suppose. It was feeling real. It was feeling very cozy and also challenging in terms of cognitive assessment. And will you share a bit how this project began? Why, for example, a kitchen and not maybe another place? Or what are the main findings of this cover so far?
Yes, so the reason why we chose a kitchen scenario for developing this real-world cognitive test battery was that we had conducted interviews with patients, and one of the common challenges that they met in their everyday lives was that they had to cook meals, and that was a big obstacle because they wanted to have friends over, but they weren't sure whether they could manage cooking meals. And so in that way, it also impacted on their social functioning, the cognitive problems in the kitchen. So based on that, we developed this task in the kitchen scenario where you are supposed to cook a meal, a lasagna, or actually in a parallel version, a moussaka, so which is like the Greek version of lasagna, I think.
Oh, okay.
Yeah.
Okay. Okay. It was quite tasty, I should say.
Yeah.
It was appealing seeing that lasagna in the oven.
Yeah.
Okay.
So yeah, the choice of the meal was kind of a little bit random, but it had to be challenging, but not too challenging. And then the task is involving measuring of 5 different cognitive domains. So we measure verbal memory, attention and working memory, and executive function and psychomotor speed. So for example, in the verbal memory task, you see a paper note hanging on a fridge. So on this list, there is 15 ingredients that you need to retrieve from the fridge and from the cupboard, which you probably remember when you tried the task. Yeah. So 15 different ingredients with specific indications of like how much fat there should be in the cream, for example, and which type of mozzarella cheese you had to get out and so on. And that was very important to encode that, because then the list disappeared. And then your job was then to retrieve as many items as possible without going back to the list to recheck. So there were distractor stimuli, different types of cheese, different types of cream, and so on. And you get points for how many correct items you get out. So that was the verbal memory task. So we tested the cooking task in virtual reality in 2 separate studies using different measures of functioning. So we used a clinician-rated measure of functioning, the FAST, and also in the other study, an objective performance measure of functioning, namely the AMS. This is a measure of activities of daily living performed by an occupational therapist. Mm-hmm. And the 2 studies actually revealed the same. So the virtual reality task was able to detect cognitive difficulties across both patients with mood disorders and patients with psychosis spectrum disorders. And importantly, the severity of the cognitive impairments in the kitchen scenario scaled with poorer real-world functioning across these patients, really indicating that it does tap into some real cognitive skills in daily life.
How was working with virtual reality? And I think that maybe you had to collaborate with many other figures, such as, programmers, informatics, virtual reality experts. And from my experience, I think that this is not always straightforward for clinicians, and it's not always easy for clinicians to deal with experts of more computational aspects that are maybe interested in setting the actual environment with technical limitations and things like that. And what was your experience like on this?
Yeah, it was actually a very fun challenge to work with people who have a completely different perspective and to get common ground in the beginning of the project. It took a little while in several meetings to get this common ground. So first we conducted interviews with people with lived experience with mood disorders to first identify the virtual reality scenarios that could be most clinically relevant. And then we had to have meetings with the VR developer about what are cognitive impairments and how do they affect people's lives and how can we measure this in a kitchen scenario. Also the technical aspects, of course, where I learned a lot from. So of course, he learned a lot, but I also learned a lot from his expertise. So that was very fun and challenging. And I think we ended up with a really good technological solution based on this kind of collaboration with people from completely different backgrounds.
Very nice, very interesting. And so it seems that you use virtual reality environments to assess cognitive function, to provide a more realistic way to assess cognitive function. But before we started actually recording this interview, we spoke a bit and you mentioned that your group is also exploring how virtual reality can improve diagnostic discrimination between different mental disorders, which is very interesting. Also because diagnostic discrimination is a real challenge that we experience as clinicians. Could you tell me a bit more about that?
So in simple terms, a major challenge in psychiatry is the lack of reliable biomarkers for diagnosing mental health disorders. So without these, it's hard to get an accurate diagnosis, which can lead to delay in right treatment. So at the NEED Center in Copenhagen, we're conducting and working on a solution with virtual reality. So essentially, we're exposing people with psychiatric disorders and personality disorders to controlled social scenarios in virtual reality, where we combine this with physical and also emotional self-ratings to better understand their responses. Okay. So different disorders often cause unique cognitive distortions or cognitive biases. Basically, they affect how people perceive and interpret the world in subtle ways, especially in social settings. So our goal is to develop a virtual reality platform that can help improve diagnosis in conditions like depression, bipolar disorder, and personality disorders. So by tracking behavioral and physiological responses, we hope to offer an earlier, more accurate diagnosis. So, for example, in a pilot study that we just conducted, including participants with bipolar disorder and borderline personality disorder and schizophrenia, they experienced different social scenarios in virtual reality, like standing in an elevator together with other people, a little bit crammed, and also standing with a crying baby, so alone in a room and with a baby that just kept crying. And then we measured their emotional and physiological responses. And what we found was that people with these conditions had stronger negative emotional reactions and also stronger psychophysiological responses compared to healthy control individuals. And we also found some diagnostic differences between the groups. So we found, for example, that patients with borderline personality disorder and also those with schizophrenia responded more negatively in the elevator scenario, feeling that more observed and feeling more unpleasant, and had higher psychophysiological responses than those with bipolar disorder, who didn't seem to mind the situation in the same way, as well as healthy controls who also didn't really mind it. And we also saw that the patients with schizophrenia had less enjoyment in a scenario with a sweet, giggling, happy baby. Okay. So they reported less enjoyment of that situation, which could be something underlying the negative symptoms in psychosis disorders. So yeah, we are really hopeful that this research will help us with providing some digital biomarkers. So combining these psychophysiological responses and emotional ratings and interpretations across different scenarios that tap into the biases that are unique to the different disorders. And then based on the profiles of the individual patient, then maybe we can help guide the diagnostic evaluation. So as a supplement really to the diagnostic interviews, not to replace them, but as a supplement.
Okay, which I think it's cool. So because maybe we are not yet to use only these technologies to do clinical assessments, but clinical assessments alone not always provides the results that you want to. So exploring like new ways to help us into this, I think it's very important. And one thing that I was wondering about, which is how much do you think that virtual environment could be further improved? In sense, for example, in the Coverage project, we have a very equipped kitchen, fully equipped kitchen, very cozy, very nice, but maybe not all the participants have this same kitchen at home. And I don't know, maybe do you think that personalized environments, maybe replicating exactly the environments of their daily life, could help participants to feel more immersed in experience? Or maybe, I don't know, using more advanced controllers to enhance the sensation of interacting with objects could be useful in terms of cognitive assessment, or maybe not? I really don't know.
I think that's a very good question. So I think we have to distinguish between assessments and intervention. Okay. So for assessments, I think it's very good to have a standardized scenario, because then you can compare people across, and you can compare people with different levels of cognitive functions in the same kind of very controlled setting. But of course, that setting has to be as relevant for as many as possible. That's why we tried to create a kitchen that was, kind of average in a way, also a bit messy, because if it was too neat, I think a lot of patients wouldn't really feel at home.
I really like your idea of messy.
Maybe less messy than it could be, but yeah. But I think for intervention, on the other hand, I think that could be really very helpful to make the scenarios more personalized. Okay. And they are also being made personalized. I know different research groups are working on that and personalizing, for example, hearing voices, the voices that patients hear, for example, in psychosis disorders, that they tune them so that they recreate those actual voices. And that makes it much more real for the patients then to talk back to these negative voices, and then they can work with that in the therapy. So I think that is definitely the way forward, to make it as personalized as possible. And that is something that the technology will also help us with in the years to come.
Okay, thank you. I did not think about this standardized features of an environment to actually assess a cognitive aspects. So we've discussed how virtual reality can enhance cognitive assessment, how can allow diagnostic discrimination. But I think that another intriguing application is in interventional settings. And what are your thoughts about this? Do you have any ongoing projects exploring VR for interventional settings?
Yes, actually, we are currently in the process of completing randomized controlled trial of a 4-week intensive virtual reality-based cognitive remediation intervention. So we have preliminary results that look very promising for 90% of the patients. So we are not fully there yet, but the results so far look very promising, showing that the intervention is not only improving patients' cognition, but also improving patients' functioning in a daily life, actually in a real kitchen where they have to cook a real meal.
Oh, nice.
Yeah. So that's very exciting. So we're, of course, waiting for the final analyses, but so far it's looking very promising. And this is something that we're going to pursue in the future as well.
Well, I put a little disclaimer here because I'm very interested in VR and I think that it will be a super important feature in I don't know if only in the future, but also in the present. But I would like to play the devil's advocate with this question. But how do you think that the use of this technology could lead to potentially dystopian outcomes? For example, I remember about reading about a study in which a patient was both embodying his perspective and his therapist's perspective. So it was like a one-man psychotherapy in which participant was both the patient and the therapist. I know maybe this is just an example, but also based on your experience with this and your imagination about it, how do you think it could lead to actually dystopian outcomes?
That's a very good question. To be honest, I'm generally an optimist, so I don't have any strong concerns about it. Right now, I'm just fascinated with the different possible applications. I think the most realistic risk that I've been thinking about is that virtual reality interventions may widen the gap in mental health care. So mental health care access, for example, if it becomes very expensive and restricted, it can lead to unequal distribution of these different cutting edge treatments. So this would be something that would be important to consider in the future of mental health treatment, that we should ensure an equal distribution of these intervention possibilities for all patients.
Okay, nice. Thank you. Let's hope for the best. And well, I read your CV in preparing this interview, and it seems that virtual reality is just one of the many challenges that you had during your career. Because as you also said at the beginning of this interview, you also worked on other fascinating projects, such as the ones investigating the EPO's role in cognitive dysfunction. Are you still exploring this line of research?
Yes, absolutely.
Oh, nice.
So while virtual reality is, of course, an exciting area of research, but I'm still very much also focusing on exploring the role of EPO in neuroplasticity and cognition. So over the past 15 years, I've been investigating how EPO can enhance neuroplasticity and strengthen cognitive functions. So in our studies, we found that increasing EPO levels in the brain, whether it's through direct treatment with EPO injections or by simulating low oxygen environments, can significantly boost cognitive performance, or at least in animal models. So right now, I'm conducting an ERC-funded study, the AltiBrain project, where we're taking this one step further. So we're testing whether combining low oxygen exposure to simulate high altitude with cognitive training in humans can lead to long-lasting increase in neuroplasticity and cognition. And in particular, whether EPO plays a key role in this process, because we know that low oxygen, so lowering the oxygen, not to a severe degree, but to a moderate degree, simulating high altitude, like in being high up in the Alps, actually stimulates EPO production in the brain. And this leads to increase in neuroplasticity. So it seems to play an evolutionary ancient role. And many people don't really think of EPO in that way. They think about blood doping, but this is really why I'm interested in these effects. So let's see, it's very exciting, and it's an interdisciplinary study. So it's a translational study where we are investigating the effects of this low oxygen exposure to cognitive training across mice and humans. So, and also looking at whether it can improve cognition in patients with cognitive impairments.
Okay, best of luck with this.
Thank you.
One of the main objectives of the ECNP podcast is to guide and inspire researchers all around the world. So when I talk with my early career colleague, well, we complain about a lot of things. We have many problems to challenge, but I think that one of the most common problem or difficulty that we encounter is how to actually manage our work-life balance. So I try to put this dilemma into your hands and ask you, how do you manage your work-life balance, and which suggestions or maybe things that may help young researchers would you like to share?
So first of all, I actually like to call it work-private life balance, because I think work-life balance is not accurate enough, because I think, work is a part of life. So it's more like work-private life balance. Because work is just such a big part of my life and I love it. So, but anyway, that's that note aside. But maintaining a work-private life balance is really challenging, and especially in research where it's very easy to get consumed by your project. So I can definitely relate to it. And I faced those challenges myself as well. So particularly after becoming a mother of 4. So before having children, I could spend endless hours on my research and I really enjoyed it. But as my family grew bigger, I had to start managing my time much more carefully. So it became crucial to prioritize things in life and prioritize my time in a way that allowed me to stay productive in my research and also at the same time being present for my family. So a lot of things like other things in life I had to down prioritize. But even before having kids, I was known by my friends and family for my strict time management. So my friends and family used to joke about it, but honestly, it's actually helped me a lot. So for example, I break down big projects into smaller projects, smaller manageable tasks with specific deadlines. And then I allocated dedicated time slots in my calendar for each task. And in this way, I can make steady progress without being overwhelmed. And also I can ensure that I have time for my family and friends without being stressed about some deadline that is approaching. And also time for other interests like traveling, for example. So my advice to early career researchers is to develop strong time management habits. So plan your work by setting clear deadlines and breaking big tasks into smaller intermediate steps. Start in good time with funding applications, for example, is also a good piece of advice. And also be disciplined about your time. So that's important because you also need to step away. It's important to enjoy time with friends and family or other activities so that you can also recharge and maintain a healthy balance. And that makes you even more productive when you then do work and you do your research, then you become energized and you can focus better. So I think, that would be my key advice for young career researchers. So time management is really key.
Okay, thank you. I will look for it. And so with this podcast, you are going to inspire many people that are going to listen to your story, to your career, and to your research. But what about your inspirations? For example, if you could choose one person, maybe a researcher, a musician, a writer, a painter, whoever you like, who you believe has significantly influenced your overall career? That's
a very good question. So one person that has had a great impact on my research is Professor Edward Vieta, who you also know very well. So he was originally the person who encouraged me to set up the International Society for Bipolar Disorder Targeting Cognition Task Force back in 2016. And it's a global network of experts in cognition and mood disorders. So my role was to found this task force and also chair the task force. And that has led to several influential applications for researchers and also for clinicians in the field. And it's also led to development of materials for people with mood disorders in many countries. So in that way, the work has been a really unique opportunity for me and also led to contributions that I wouldn't have been able to come up with alone. So without this task force. So I'm really extremely grateful to Professor Vieta for believing in me and for also encouraging me. So I think more broadly, I think mentors are very important for young career researchers. So if you have anyone who wants to mentor you, that's really something essential, that someone can promote you and believe in you. Also, when you doubt yourself, then there is this person who says, you can do it. And I know you can. And then you will actually do much more than you thought you could. So I'm very grateful for that. And I hope everyone has the opportunity to get such a mentor.
totally agree. While preparing for this interview, I was listening to the ECNP podcasts, and I particularly listened to an ECNP podcast featuring Professor David Nutt, who made a statement that caught particularly my attention. I'm going to read it. So he said that the greatest thing in the world is to discover something new. And when I heard this statement, I was like, oh, it is such a huge statement. What do you think about it? How much do you agree with this statement? And what does the concept of discovery means to you in the context of modern research?
So I completely agree with Professor David Nutt's statement. So there is something truly exhilarating about discovery. So in research, discovery is just not about finding something entirely new, but it's about uncovering new ways of understanding the world, and particularly within neuroscience and psychiatry in the brain. So for me, it's when the moment of when all the hard work and the data collection and experimentation finally click together and reveal something that wasn't obvious before. So this is really a fantastic moment and something that really drives me in research.
I challenge you with a bet.
Okay.
Let's make a bet, and we will listen to this podcast in 10 years or maybe 5, because things happen so fast in these days. And we will see if we were right or not. So regarding cognition, what aspects that are now actually not yet fully considered or are only minimally addressed do you think that will be crucial for the future in this field?
That's a very good, fun bet. If I had to pick one area for future cognition research, I think emotion dysregulation across psychiatric conditions would be central. So it's a core feature across so many disorders, from depression to bipolar disorder and ADHD and different personality disorders. So addressing emotion dysregulation more directly will be very crucial for improving outcomes and functioning. I also think the gut-brain axis will gain attention, but perhaps more emotion regulation and how it links to cognitive function will be a major target for treatments in the coming decade. So let's see if this holds up in 10 years.
Okay, let's see. Well, I really like emotion dysregulation, emotion regulation, things like that. So I really hope that you are right about this. Also because I think it's a super important topic.
Yes, definitely.
Okay, well, thank you so much, Kamilla. It was a very fun, interesting and inspiring discussion. So I feel very lucky to have had the opportunity to actually interview you. I'm sure that our listeners will find many ideas that will guide their clinical and research work. Many thanks to the ECNP that sponsored this podcast. And many thanks to all of our listeners. And be sure to catch up future episodes of the ECNP podcast, where we share experiences from leading experts in neuroscience research. Thank you so much, and see you next time.
Thanks for listening to this podcast from ECNP. The views and opinions expressed in this podcast are those of the interviewee and do not necessarily reflect the official position of ECNP. The content of this podcast should not be used in any way as the basis for treatment decisions.